Good morning, everyone. I hope I'm audible. So we will start from where we left last week. So we were discussing about the binary trees. Let's do a quick recap now. We started with a new module last week, like trees, and we saw binary trees. We saw type of binary trees. We saw different properties of binary trees. So, and later last part of the class, we performed some operations on the binary trees, like finding out the leaf nodes, finding out the count of total nodes, height, things like that. So I'm going to perform few more operations now on the binary tree, which are very, very popular. I mean, any book, any text, or any reference where you pick up, you will see these operations almost everywhere. And these are called traversals. Traversals means, I mean, literally, I mean, they mean like traversing. I mean, you are visiting a node. All right. So let's look into this, what exactly they mean. All right. So in binary tree traversal, please pay attention to this. Some terminology will come here, which will be important for you. In a binary tree traversal, each node is visited only once. Okay, so we are going to visit a node once. During this visit, all actions with respect to this node is taken. For example, either we are going to process this node or print this node. So from the demonstration perspective, we are going to print that value. All right. Now, since we know like a binary tree, there is a root, and then there is a left subtree, and then there is a right subtree. So we will have few notations here, like L represents moving to left, R represents moving to right, and V represents visit or process the node. Okay. So how many combinations will be possible? Like you can see there are 6 combinations which are possible. In the green color, 3 combinations, and in the red color, 3 other combinations are mentioned. And the 3 combinations, for example, LVR, LRV, and VLR, here you can see the left move is performed before right move. So L is coming before R, right? And if you see the other 3 red color movements, like you are visiting VRL, here right movement is coming before the left movement. Okay. So as a convention, normal convention, like okay, for example, if there is a binary tree and if we have to visit the complete tree, okay, we have to process the complete tree one at a time, taking one node at a time. The convention is that we will go to the left side first, and then we will go to the right side. Okay. So what does it mean? I mean, we are interested in taking those movements where L is coming before R. Okay. There is no technical limitation, I mean, for this convention. Only, as I mentioned, it's just a convention. I mean, there is no, it's not like this that you cannot do right before left. Okay. That's not the case. It's just a convention. All right. So the traversals which we are interested in will be only LVR, LRV, and VLR. Okay, because here left movement is coming first before right movement. Okay, and how do we technically, in English language, how do we define these terms? LVR is called in-order traversal, VLR is called pre-order traversal, and LRV is called post-order traversal. Why this name is there? Because if you see in order, the visiting, the V part or processing part is happening in between, left and right? In pre-order, visiting or the processing part, V part, is happening in the beginning itself before L or R can take place. Similarly, with the same logic, in LRV, if you see, the visiting or the processing is happening in the end, right? So that is called a post-order traversal. Okay. In addition to that, we are going to use one more traversal, which is called level order traversal. Okay, this is simple. So in level order traversal, what happened? You start from the root, which is at level 1 in our terminology, and you start processing the nodes one at a time from left to right direction. Okay, so that's a very simple one. I mean, you just simply number them from left to right. Let's see an example. So a simpler example first. There is a binary tree with root A, 2 children B and C, and when we are going to perform traversals on this particular tree, the reference to root, which is A, is given. Alright. So what will be the in-order traversal? The in-order traversal will be that you will, through A, you will not process A. Okay. Through A, before I do that, let's see why in-order traversal is BAC. Okay. Because reference to A is given, correct? But I am not going to process A because I need to process A's left child first, which is B. Okay. So now I have the reference of B with me. Now I am not going to process B, rather I need to process B's left child first, which is null. Okay. So LVR, I need to do in order LVR. Left child of B is null, so L is gone. L is done. Now V means processing on printing, so I will process B now. So I will print B. And then comes L is done, V is done, R is done. R has to be done. So what is R of B? R of B is null, right? R of B is null. Left child is also null, right child is also null. So I will simply, I will not do anything out there. Rather, control has to decide where it needs to go now, right? So if you think from the logical perspective, left child of A is completely done, right? B is completely done. Now my turn is to process that node from where I started the journey, that is A. So I will print A, and the same cycle will be repeated for C. Okay. Why is it so? So this is a recursive call which is happening starting from A. I will not process A, rather I will go to left of A, which is B. I will not process B, rather I would go to left of B, right? But left of B there is nothing, so I will process B. Then I will take the right child of B, because it is LVR, nothing is there on the right side of B, so my job is done. B subtree is completely taken care of. Now scale up one level higher, so you will see left child of A is completely taken care of. L is taken care of for A. So now you will process A. It means you are going to print A. Now the same cycle will be repeated for C. So you will take C, but you will not process C, rather you will go to its left, which is null. Then you will process C, then you will take its right child, which is null, so the job is done. Okay, so this is how we perform in order traversal. Let us take a bigger example to understand this. Alright, so now if you see, like the tree is big, okay, many levels, height is 4, and many nodes are there. So what will be its in order traversal? So we will do one traversal at a time, but let's understand this. So starting our journey from A, there is no doubt about it, because trees are normally, I mean most of the cases, it's possible to perform a tree operation starting from the node. We need some reference, right? So LVR, in case some of you joined late, or in case if you missed out the logic, it's a simple one, but I am repeating it again. Reference to A is given, and I am going to perform in order traversal, which is LVR. Okay. So I am not going to process A, because first I need to go to the left side of A. So I will go to B. Alright. But B I will not process, rather I will go to its left side, which is null. So now for B, L is done, left side is done because it is null. Now comes the turn of V. V means visiting or processing the node. So now at this point of time I will print B. Okay. So in L order traversal, LVR, L is done, V is done for subtree B. Okay. R is remaining. So now I will go towards the right side of B, which is D, right? But I will not process D because the same LVR process will be repeated for D again, right? So I will not process D, rather I will go to its left side. But here in this particular case, left is null. Okay. So for D, left is null, so L is done. Now the terms I will process D, which means I will print D here. Okay, so L is done, V is done. Now I will go to the right side of D, which is also null. Okay, so far I have printed B and then D. When I am done with it, you can see that I am done with the left child of A, right? I am done with the left subtree of A rather. So it's my turn actually that I need to process. I will not process A because it is LVR, right? So now since my L part is done, I can process A now in this condition. So I will print A here. Okay. Now L is done for tree at A, whose root is A. My L is done, processing of A is done. Now I need to go to the right side of this tree. So right side of this tree means what? That I will visit C. I mean through C. I will go to its left child, which is E, but I will not process C, I will not process E, rather I will go to E's left child, which is G. I will not process G also, rather I will go to its left child, which is null. So L of G is done, left of G is done. Now let us process G, which means print G. Okay. Now I will go to the right of G, which is null. So G is completely taken care of. Now I will go to E. For E, left part is taken care of, so I will print E, and the right side is null. If you see for C node, left subtree is completely taken care of, so I am good to actually print C at this point of time. And if you repeat the same procedure for the right subtree of C, okay, you will get complete in order, which is written as like this. You can see B, D, A. You first printed B, then printed D, then A, then G, E, C, H, F, I. Alright, it's a simple one. Now, what is pre-order traversal? Pre-order traversal, as we noted it down, it is actually VLR. Okay, so what is VLR? I mean, the node which is given, the first reference which is given to you, you will process it, print it, and then you will go to the left side of it. And after finishing the left side of it, you will go to the right side also. So it is called pre. You process it first and then you go to L, left side and right side. Okay, so it's a very simple one because the moment you hit a node, you will print it. Okay, so the reference to A is given. Okay, so that will be A. I will print A. So my visiting or processing node for A is done. Now what I need to do, I need to go to the left side of it, which is B, right? So the moment I come to a node B, I need to print it. So I will print B. Now for B, since processing is done, I need to go to its left side, right? VLR, left side is null. So I need to go to the right side of B, which is D. So D, again the same procedure will be repeated here. In for D, left and right both are null. So I will, first of all, I will print D. Then I will see what is left child, which is null. So I will not do anything. I will see what is right child. I will not do anything. So I am done for the complete ABD printing. ABD printing is done. Same procedure will be repeated on the right side of A. Okay, so what will it be? What the final output will be? ABD CEG FHI. So you see, like it's a simpler one because as you traverse the node, you process and print it. Okay. Let's see the post order traversal. Okay, what is post order traversal? That we are visiting left first, then right, and then in the end we are processing the node. Okay, so what does it mean? Reference to A is given, so I am starting my journey from A. I will not do anything, rather I will go to its left, B, I'll not do anything here, rather I'll go to its left, which is null. Okay, so L part for B is done. Now, can I process B? No, because I need to visit right child of B first, right? So I will go to D now. So I will print. Now for D, I will not process it. Rather, I will go to its left child, which is null. I cannot still print D because I need to visit its right child, which is also null. L left child, right child, and then process the node. So left and right both are null. Then I will print D here. Okay. So if you see for node B, B for boy, my left is done, right is done. So I can print B. So for A, my left subtree is taken care of. But I cannot still print A because it is L. First you need to finish the left subtree first, then you need to finish the right subtree first, and then you can process the node A. So from A I will not do anything, rather I will go to its right now. So I will hit node C. I will not do anything here, I will go to its left, which is E. I will not do anything here, I will go to node G. I will not do anything here, I will see what is the left, which is null. Now I will not print G, rather I will see who is the right child of G, which is null. So now it turns for printing G. Okay, repeating the same process, you can see the post order traversal will be DBG E HIF CNA. A is coming in the end. Okay. So if you see these traversals so far, which I have performed here on your screen, in order traversal, if you see this property is going to help you, so I request you to just pay a little attention here. When I see in order traversal, the very first one, A is somewhere in between, right? And who is on the left side of it? B and D, because they construct actually a left subtree of B, A, right? So B and D anyway are coming left of A in the traversal also. And other elements are coming on the right side of A, which are making the right subtree of it, right? If you see pre-order traversal, root is the first one, right? Because as the moment you hit a node, you need to process it. If you see post-order traversal, the root is coming in the end, right? Because it will be the last node which you are going to process. This is a very important property which is helpful to construct a unique tree. Okay, we'll discuss it in few minutes. Now, what about the level order traversal? It's a very simple one, as I mentioned. Starting from the root, left to right, one level at a time. So it will be A, B, C, D, E, F, G, H, I. You process A, then they'll come to level 1. A is at level 1. Then you come to level 2, left to right, B, C. Then you come to level 3, left to right, D, E, F. Then you come to level 4, left to right is G, H, I. Okay, so this is also an important traversal which is utilized somewhere at few places. Alright, so I hope this concept is clear, and let's move forward. This is another example which is, can you name like what is this tree called? This looks a binary tree. Only difference is like the way I have depicted it on the diagram, and null childs are shown with a blue stub. Okay, so blue stub actually, which you see blue rectangles here, they are called actually the null child, right? So some of you actually answered it correct, like this is a very specific variety of a binary tree. This is definitely a binary tree. Some of you are saying perfect binary tree. This is not perfect, by the way. Right, this is called an expression tree or arithmetic expression tree. Some of you answered it right. Okay, I'm not going to repeat it here, but I want you actually to let me show you all the traversal here. What you need to notice here is that all the leaf nodes, I'm not talking about the blue rectangles. Okay, blue rectangles are null children, right? I'm talking about all the leaf nodes. Who are leaf nodes? whose both the children are null. So for example, A, B, C, D, E, they are leaf nodes, right? So what you notice here is in this kind of expression binary tree, arithmetic expression binary tree, all the operands, right? A, B, C, D, E are operands, and plus, minus, multiplication, division, and all these are operators, right? The property of these expression trees are that operands are, all the leaves are operands, and all internal nodes are operators. Okay. Now, if you take the traversals of these trees, like in order, pre-order, post-order, you are going to get the corresponding infix expression, postfix expression, and prefix expression, right? And if you recollect, during the stack module, we saw an application of stack, that how are we going to evaluate a postfix expression using stack, right? So similarly, similar to postfix, there is something called infix expression. Infix expression is what we use on a day-to-day basis as a human being, which is understood to us, where operator come in between the operands, right? For example, if you read the very first expression, which is in order traversal, A divided by B into C into D plus E. This is what we, as a human being, we are familiar with. Bodmas rule, right? Associativity, left to right evaluation. This is what we are familiar with. Post-order traversal, here operators are coming in the end, towards the end. Pre-order traversal, operators are coming in the beginning. Okay. This is not human readable and they can't process it so quickly, right? Label order traversal doesn't make much sense here, okay, because it represents a traversal, that is fine, but this is not, at least I am not aware of any real application of a label order traversal in an expression tree. Okay, if you come across, please share it with me. So with this, I will move forward. So we have seen the traversals, right? In order traversal, pre-order traversal, post-order traversals. Let's quickly write down the functions for them, right? And there is nothing to explain because these are, you can make it out very quickly, and you can make out yourself that these are recursive formulations. These are recursive functions written in C kind of language. So let us see the first one in order. Left hand side, the first one, the topmost. If pointer is not equal to null, okay, so reference to the root is given, and if it is not equal to null, you don't process it. You rather go to its left side. Once you are completely done with the left side of this pointer, right? See, in order is again a recursive call in the first statement inside if. So this will keep on going towards the left. Once you are completely done, then you will print the data which is red line, and then you will go to the right side of this tree, which is in order. So that is the reason it is called L, which is left child, V process, which is I am doing as a printing, and then I am doing the right child. Okay. Similarly, post printing is happening in the end, pre printing is happening in the beginning, and otherwise two recursive calls, right? Very simple formulations here. There is nothing to explain. All right. Are you able to see my slides? Because one or two participants are saying that my slide is blank. Okay, so participants who see a blank slide, I would request you to rejoin, because there is nothing which I can do from my end. Please rejoin. Now, couple of exercises. Okay, so as usual, like sometime actually, like participants, they say like, okay, they are having it, they are finding it difficult to read the books or reference. So I have prepared some supplementary notes which I am sharing all throughout. So I'm also sharing, going to share some notes today which are about the traversal functions, but in an iterative fashion, not the recursive fashion. and level order traversal function. All right, and some code actually which will implement the traversals which we have just reviewed. So some of you are already doing it proactively, like please write the code yourself, practice it. And there is a tree which is shown on the screen right now. I would request you to perform the traversals and share your answer on the chat box. So let's do in order traversal first. Let's do only in order now and share your answer, please. Right. Okay. So several of you actually are started sharing your answer. So unfortunately, I cannot check for each individual. So answers are given here. Let's see in order. DGBA, right? So how is it DGBA? Because I will start my traversal from A. I will not process. I will go to its left B. I will not process. I will go to its left, which is D. I will not process. I will go to its left, which is null. So since left of D is null, my journey towards left stops here. Then I will process D. Right? L is done. Now I am doing V part for D, which is I am printing D. Then I will go to its right child, which is G. I will not process G, rather I will go to its left, which is null. So now I will process G. I will print G. Then I will go to its right, which is null. So for subtree B, its left is taken care of. Now I can print B. And right, there is nothing, so I will not do anything. Now for A, complete left subtree is taken care of, so I can print A happily here. And the same procedure for the right subtree of A. Okay. So similarly, I mean, whenever you see exercises, these are exam representative questions. I would suggest very strongly, please attempt and share your doubts on the forums. Some of you are very promptly doing it. Now, I don't have an exercise symbol, but this is something which you need to perform and observe. Share your answers with me, like what do you see here? Okay. So, I mean, if I see a cursory look at the tree, this is not a binary tree, rather it's a n-array tree, right? Because one child of C is having 3 children, right? So it's definitely not a binary tree. So what I'm supposed to do, right? I need to convert it into a binary tree form, and then I need to perform a traversal, which is pre-order traversal. So what is overall, and these 3 points which I have mentioned, what is my observation? Okay. So this is something for you to do and share your answers or thoughts on the forums. So you need to convert definitely, like some of you, as you are saying, like LCRS. Yeah, you need to take that approach and convert it into a binary tree using that. Let's move forward. No, so expression binary tree I have already discussed with you, so I would rather skip this slide. Okay.